challenges for safety in new normal. And for this session, I would like to call upon the dais our session chairman, Shri D.R. Mistry, Deputy Director of Boilers, Vadodara, to please come up on the dais and occupy his chair. He is BE Mechanical from the 1987 batch from LE College of Engineering, Morbi. He worked in captive power plant at different levels. He passed second class boiler proficiency in 1994. He joined Government of Gujarat in October 2002 as Inspector of Boilers and served at different locations. I would like to now request Dr. Utpal Pandya, Professor and Head Instrumentation and Control Engineering, Sarvajanik College of Engineering and Technology, Sarvajanik University, Surat, to please come upon the dais and occupy his chair. He has received BE degree in Instrumentation and Control Engineering from SS Engineering College, Bhavnagar. He has published and presented and received various research papers. He is a professor and head at Instrumentation and Control Engineering Department. I would like to now request Shri Pratap Makwana, Forbes Marshal, Pune, to please come upon the dais and occupy his chair. He's a boiler efficiency and safety professional with over 15 years of experience in the field of combustion efficiency, safety and controls at Forbes Marshal, India's leading process and energy efficiency firm. He is presently heading the Boiler House division and works with plants across various sectors for combustion cessation, energy optimization, safety and digitalization of the boiler house. I would like to now request Shri J.B. Suhag to please come upon the dais and occupy his chair. He is a mechanical engineer and first-class boiler proficiency engineer from Gujarat Boiler Board. Currently thermal power consultant and earlier associated with Rebo Industries Limited as a Vice President Western Region and have more than 40 years of hand-on experience in the field of thermal power sector from low, medium and high capacity boilers and power plants. I would like to request, I would like to inform that for the corporate presentation, instead of Shri Chetan Shah, Mr. Nimesh Patel, Vishal Thakkar and Rhythm Shah, they'll be taking care of the corporate presentation. Please take note of it. And now I would like to request our session chairman to please take over the session.
Good afternoon. I think having delicious lunch from Saket team, I hope all will get ignited for the longest session of the conference. Though it is the longest session, but quite interesting session of the conference. The Saket team has gathered 4 diamonds in a ring of this session. So I request all delegates to take the maximum advantage of the presentation for which all faculty members are here. First, I would like to invite Mr. Utpal Pandya to deliver his presentation.
Okay, good afternoon everyone. Am I audible? Little bit tough session after the lunch. Okay, I'm little bit, I'm from educational field. I'm not practicing engineer. So when I was contacted and asked to write something about the post-COVID scenario, I thought, what can I write? What can I do? So I just started to search the net and what is happening in outside India after post-COVID. So I found a few interesting facts. In fact, they have started to practice it, and I hope the technology they are going to use, they are using will come after 5 years or 10 years in India. So I will touch few points on that. COVID-19 has affected our life like anything. It has, it has impacted all the sectors. It has changed our way of life. However, it has opened floodgate of opportunities for boiler industries. Because although the lockdown was there, but there are some essential sectors providing services to the society, like pharma sectors, energy sectors, hospitals, industrial buildings, power plants. So they have, these industries were very much pressurized at that time, lockdown time. So when these plants work continuously, it is required that it should be maintained properly. Periodic inspection is required of the boilers and its associated equipments. Once the periodic inspection is carried out, it will help to plan periodic maintenance. So if we do the periodic maintenance, it will lead towards the energy saving. Not only the energy saving means the cost saving, but also the environment. It will help to protect the environment because carbon emission and other things will get reduced through periodic maintenance. So I thought, all this thing, how the steam is produced and what are the components, and the sectors that has helped us a lot. So here, I come across the frontier technologies which the people are using to solve the problems that has created post-COVID. So, the frontier technologies like, that there are 11 technologies which are considered as a frontier technologies. These technologies are going hand in hand. Means you can't say that our industry is not helpful, is not going to benefit from these technologies. So, there are 11 technologies like AI, IoT, big data, blockchain, 5G, 3D printing, then robotics, drones, gene editing, nanotechnologies, solar photovoltaic. Out of this, I see a lot of potential that can be helpful to boiler industry is AI, artificial intelligence, IoT, and the drone. Let me start with the drone, how it can be helpful to the boiler industry. Boiler inspections are mandatory. Every year, all the industries has to carry out the maintenance. So, means it is necessary from the laws, and the insurance company also pacing to carry out this inspection. However, some organizations recommend conducting an additional external inspection halfway through the year while the boiler is under pressure. Normally, boiler is required to be at the zero pressure and do the maintenance, do the inspection work. So during the inspection, external, internal inspection is carried out, and you'll find the checklist. What are the points one should check during the external boiler inspection and during the internal boiler inspection. So as most of you are practicing engineer, you know what are the things which can be carried out for the external boiler inspection, like boiler room conditions, nameplate data, safety valves, control safety devices, piping, fresh air for combustion. Okay, so these are the points or parameter which can seen during the external inspection of boiler. Now for internal boiler inspections, the walls and surfaces are observed by the boiler inspector. Water side areas are inspected, so that includes the blow off, water connections and steam areas. And the fire side conditions, so like boiler including superheaters, deaerators and economizers, all the things are observed as an internal inspection. Now here is a catch. For internal inspection, scaffolding is required to be created so that the inspector can go inside and see the internal parts. So here, is it possible to use the drone to do the visual inspection of internal boilers? Okay. So if you search on the net, you will find few companies which are offering these services, not here but in abroad. And if you read the reports, the financial report, it says that there are a lot of benefits to use the drone for internal inspection of boiler. So like the advantages like the safety, it gives a safety to the inspector. No need to go inside. You can, visual data is available on the monitor and can be done. Savings, cost is saved because no scaffolding is required. And in fact, if the cost is saved, then boiler inspection frequency can also increase. Okay, so it will lead to the, the boiler efficiency increase in savings and helpful to environment. Okay. Then access. Using a drone for indoor inspection, inspector can get a close view of burners, tubes and other parts of the boiler that are typically hard to access during the manual inspection. Okay, so there are certain areas which can, which can be overlooked by the boiler inspector. So drone can give a better access in certain area. Drone can give better data. So higher quality visual data will be available through the drone instead of manual data available. Okay. And the data related with the specific burners and openings, that will help to, to plan the things in a better way. The drone inspection can help to reduce the greenhouse gas emissions. As the decreasing the cost, they increase the frequency of inspection. So CO2 emissions and other things can be reduced through increased boiler inspection. However, the usage of drone is not simple as we think. There are a lot of challenges. Like boiler present many challenges for flying, since the space within them is tight and full of objects for drone blades which can be heated. Okay, so drone can be damaged. So simple drone that we are seeing cannot be used for the boiler inspection. Another thing for the drone is it should be stabilized once it gets inside the internal part of the boiler. So stability is a big issue in the internal parts. Okay, so flying inside and the obstacles inside the boiler is a big challenge for the drone. So different kind of drone design is required for that. Apart from that, the parameters like weight, flight capacity, battery options and charging, and compliance with hazardous area classification, that is also required. So, one of the drone proposed by one of the company, is like, this is the design of the drone, which can fly inside the boiler. And, it can avoid the blade cannot get damaged, and it can take the visual data without any interference. Okay. So this is about the drone, the frontier technology, which can be helpful, which can be useful in future. Apart from that, the data monitoring. As much as we have the data about different component of boiler, a lot of things can be predicted. And that way, the boiler life cycle can be increased. So here, if you want to monitor the equipments of boiler, then seamless monitoring is required. So for certain parameters like water temperature, water leakage detection, pressure sensors, okay, that can be monitored wirelessly. So wireless data monitoring system can be helpful in this case. So you can have a lot of data, and data can be, from the data, many things can be planned. So this is a typical structure for wireless monitoring system. This is the architecture of wireless monitoring system. Like you have the sensors, wireless sensors, require gateways, and then for the software choices, you have the cloud, or maybe local server, or maybe remote server. Okay. And this is, the typical block diagram or the pictorial representation of boiler used in the hospital setup, because for boiler industry, hospitals are the new customers, in fact. Okay. However, there are again challenges for wireless monitoring system. The monitors, the wireless sensors require to be networked. Some 3G, 4G network is required to be established. And the data should be available to the management, to the dashboard of the management. That means the management is sitting somewhere else remotely in some different cities, and the data should be available on the desktop. Then only it will be useful, or the system will be justified. Okay. Then the system must provide automatic alarm notification to assist the monitoring and maintenance work. So some sort of, the feedback, not the closed loop, but at least some alarm points, some audible or some message sort of thing should be generated through the system. So these are, the challenges. Till date, in industry, the closed loop control is not, wireless closed loop control is not implemented due to the reliability issues of network, okay, wireless network. The third point, that is, the control part. So inspection, monitoring, and control. The three things can be helpful to the boilers and to increase the life cycle. So all the parameters, 3-element boiler, 5-element boiler systems. Okay. Now all the parameters of the boiler, like you take the furnace system, then the boiler part, the draft system, all parameters are interacting. So if you have big data, if you have a lot of data available, you can establish the correlation between different parameters, and from that correlation, it is possible to work out the best PID settings, proportional, integral, and derivative action settings. Okay, so because ultimately it is going to be at the control part. It may be single loop controller, it may be DCS or a PLC. Ultimately, it is going to have a PID control. Okay, so using the AI tool, artificial intelligence tool, it is possible to establish this cross correlationship between different parameters. So, many companies will provide the 7-element boiler control system. So all the parameters which affect the boiler efficiency, boiler performance, can be integrated in a system. So if one parameter gets disturbed, all the parameters will be taken care. So this is possible if the AI tool is used for data analysis. So these are the references that I have used to review this. I think it is in the Steamtech magazine. You can refer it for further. So thank you everyone for this.
Thank you, Dr. Pandya, for completing your presentation.
Thanks to Saket and Steamtech for allowing us to present and to discuss. So without going much more briefing, I would directly like to go to the session, and I would like to carry forward from the morning good part what we have discussed. So Professor Utpal has briefed about the IoT, digital, and our context of this Steamtech is that learning from the user point of view what we can do better post-COVID era. So taking ahead with this, there are a lot of buzz about the digital and IoT and cyber system. So before going much more detail about the boiler house part, I would like to broadly go into this digital part, how the Forbes Marshall approach is there. So as a Forbes Marshall, our main focus is the customer benefit, and we see that the connected devices, the equipment level as a connected futures for the user point of view. So if we see that all the equipments, hookups or equipment levels, starting with the boiler house, parameter connected on the cloud, we see that lot of diagnosis will be available, and with this diagnosis and the process knowledge what we have and the problem what user can encompass, we can do the better analysis and can identify the sweet points, best operating practices with that. From this learning, we identified that we came to know that who says the best operating user at par, we identified that there were gaps still available. So that was the further chance to identify the peak performance for that user also. So this learning, this collective learning will help all the user to overcome this kind of situation and to sustain these situations when this kind of situation will be available, and to grow in better way with the reduced steam cost, reduced energy cost, and the better efficiency. So this is the way the Forbes Marshall approaches with the digital part. With this, the predictive analysis will be always available with the connected sites on the cloud, connected boilers starting here with on the clouds, and we can identify, we can further improvise for that process, for that operating condition. Now, going into the slightly more detail with this part, if we can say that connecting the boiler house on the cloud or connecting the equipment of the boiler house on the cloud, what can be the benefit we can expect? Starting with that, the specific fuel consumptions, specific steam consumption, which is also after the specific fuel consumption, specific steam definitely is going to utilize in the plant, process side, plant side, to conserve in the form of steam and conserve in the form of fuel. Also, to identify the best steam pressure, best feed water temperature, having the best condensate recovery factor available with this diagnostics available with the digital connected sites. Now, how it will further improve the performance of that particular boiler house or particular equipment, that it will give the threefold advantage, starting with the operator side, which is a direct user at the first standpoint, if I'm not mistaken. And taking ahead with this, that first user point is always connecting, always talking to the second level, which is nothing, which is not anyone, but he is or herself is the plant manager, or you can say at some extent shift in charge in the small textile industry, or you can say the supervisor. He will be, or he or she will be happy to identify, happy to know that these are the sweet points for the boiler house is maintained. There are the no downtime for the boiler startup post-COVID. There are no any mishaps available, and he is able to sustain his efficiency. He will be more happy to denote this to the enterprise or owner side. And owner will be happy to know that he is having the best steam cost, best operating cost for that boiler house, for that plant. So these are the way we are connecting here. Of course, all these users are affected with the load variation, plant operational conditions. 90% of them we identified, yes, there was a fluctuation available, and to overcome these fluctuations with the better way, this is the way we can connect the boiler house on the cloud, and the digital era can play a vital role on that. Now, directly putting into the boiler house, the efficiency part first. So I will not go into the much more detail about the efficiency formula and all that, you know better. But we can discuss in question answer session also. I am carry forward this with the what Mr. Vyas said about the fuel cost. So with this, the 2% is the fuel cost. What he has said, what he has described for the dairy industry. This fuel cost can be the 5% or 10% depending upon the type of industry what the boiler is burning the fuel. So I am taking, because we are much more focused for solid fuel side, because oil and gas sides there are the price rise, all of that, due to that steam cost cannot be thinkable the way which we were used to imagine the pre-COVID era. So with this, if I can break up for the solid fuel boiler operation cost, generally, as Mr. Vyas said, it's in the tune of 50 to 60%. So what it says? So if you say that your boiler, let's say your 5-ton boiler, which you are procuring in the roughly in the tune of 1 crore or 1.25 crore, it's operational at the 3-ton average load. So that will give you around your fuel cost will be yearly in the tune of 5 crore rupees, roughly. That is as per the today's price rise, or you can say last 1 month's price rise of around 13 rupees or 15 rupees of Indonesian coal price. So this is the way fuel cost largely in the solid fuel boiler side. Rest of the costs are the maintenance cost, electricity cost, all of them will be there. But the fuel cost is a major cost for the user point of view, and the user is more worried on that. So when he installs the boiler, he is keeping in mind that my boiler will give always the rated efficiency, but it's not true. The boiler gives the actual efficiency which might not be rated efficiency. And from the audit reports and from the survey what we conducted into the boiler house, we came to know that this efficiency is derated in the tune of at least 15 to 20%, and sometimes it's in the tune of 40% for the manual fed boiler also. So there is a huge opportunity for that. So this gives us the trigger that what we should do to optimize in terms of the energy, boiler house energy, that gives the direct trigger about the optimizing the efficiency of the boiler or the fired furnaces. I will not go to the equations that you know very well. The boiler efficiency, thermal efficiency can be directly is the percentage of the heat input burnt inside the furnace which is utilized to generate the steam at the outlet side. That is the direct efficiency. And the indirect efficiency, you know, 100 minus the breakup of the losses. That these are the losses are the dry flue gas loss, moisture loss, radiation loss, on-off losses, purge losses, etc. And at par, these losses also, there will be the loss of blowdown loss will be there. That is not a part of indirect efficiency, but it's a loss. So I will not go into the detail, but one thing what we need to keep in mind, how we can optimize, how we can reduce these losses so that user can have a best operating steam cost. So as I mentioned that without going into the equation side, I can give you the one simple problem statement. What we came to know, and which is generally true not for the pre-COVID or post-COVID era, it's true for all situations. Any solid fuel boiler operating with the indirect efficiency in the tune of 82 to 84%, and we came to know from the connecting all the boilers so that the indirect efficiency was in the tune of you can say 80 to 84%, but you can see the variation of steam to fuel ratio. It is in the tune of almost 25%, 3.5 to 4.5, which gives us another trigger that what we can do to further improvise on this. So there is always a chance of 5% improvisation, as we have in the first sessions already it has been spoken out, again reiterated by Prem Bhagwat also. Always a chance of 5% reduction into energy cost, and further can be reduced down by 5 to 6% more with the connecting the boiler in the cloud, so that it will give the advantage not into the energy efficiency side, but to the safety side also. So much things has been said on this, that the pre-COVID era, what was the fuel price, and post-COVID era, what is that. So I will give you quickly that from our energy conservation reports and our knowledge what we carry forward and what we are in the field, that you can see the steam cost of the Indonesian coal. I have taken 20th March price, 20th March 2022 price, which was roughly in the tune of, due to the geographical era for that plant, varying from the 13 to 15 rupees, and you can see the steam cost is 2.3 to 2.5, and now it has been climbed to 2.7 at some extent due to the 17 rupees of few Indonesian coal prices. The pre-COVID era, which it was in the tune of 6.5 to 7, which was again said by and confirmed by Purohit also, and Amit Vyas also repeated. Now rice husk and biomass is having a variation, which is in the tune of 40 to 50%, but not that much like the variation we see into the Indonesian coal. In the pellet is again the non-fossil fuel, so there is not much more variation, but slightly costlier than the biomass. And you can see the price of the furnace oil and gas, particularly natural gas. The steam cost is now climbing toward the 5 rupees. Imagine, it is almost doubled than the pre-COVID era. So this again gives us the trigger that what we should do. And Indonesian coal and firewood, due to the rise of all the coal prices rise, the firewood which was available at the 2.3 rupees or in some extent of the south 2 rupees also, now it has been climbed to 4.8 rupees and 5 rupees also. My friend from the south can also watch for me on that. Now what it says for us. So if you can see that I should keep in mind what should be my ideal steam to fuel ratio, ideal SFC. So typically for Indonesian coal, we are for process industry, for the typical feed water temperature, we are able to achieve the ideal steam to fuel ratio with the best operating boiler with the plant load condition in the tune of 6.5. So but user only getting the 6 steam to fuel ratio. So what it says, the steam to fuel ratio of 6 instead of 6.5, he is losing 8%. And what it says for the boiler capacity for 5 ton, where the fuel price were the 6.5 rupees pre-COVID era, and now in the month of January 2022 it was 11 rupees. So you can imagine for the 5 tonner boiler he is losing 62 lakh rupees, and which was earlier 37 lakh, and for 10 tonner 1.2 crore, and for imagine for 15 ton 1.87 crore. So it's a huge loss. So how can user improve the steam to fuel SFC, steam to fuel ratio, so that he can narrow down this loss and can have a better efficiency available for that boiler house. So what we suggest to the user, and what user can come up through, that connecting the boiler house on cloud will help us the sustaining the boiler house, first uptime, then efficiency, and then safety. Sure, safety is the utmost priority, it cannot be lived, but all these three put together will suffice the requirement and will give the better advantage. So with this, what it will do, it will increase the uptime due to the availability of the sensors directly connected on the cloud, and the boiler on the cloud, we will have a better analytics available. The user can compare his boiler operating practice with the boiler operating practice at par the best level, and that gap can be filled by the Forbes Marshall. And again with this, the user can get the advantage of the reduction into the energy bill. It is also, he is getting the reduction into the emission level also, because the lesser fuel consumption, and he is also getting the advantage of lesser water consumption also, because at the end the best steam temperature will be available with the lesser fuel consumption and lesser feed water temperature, lesser feed water utilization, lesser backup water utilization. So that will give us the utilization into the reduction into the fuel cost at the end. So this is the way we suggest, and this is the way it has been done, that efficiency and safety monitoring equipment installed into the boiler house with this era, you can get the equipment on the cloud, and with this equipment on the cloud, we have thousands of energy audit reports available with us. So we can identify the sweet point for that boiler house, what should be the operating condition, what should be the output, set point or control variable for the IDFD feeder should be triggered for that operating condition. And at the end, we can fire this set point back to the user, can tell them you need to modify this set point with this percentage, and you need to narrow down your operating KPI. Operating KPI means steam to fuel ratio, indirect efficiency, combustion parameters should be narrowed down and should be trimmed down such that you can get the better efficiency and safety also. Lot of has been said about the boiler is the heart of steam system. I will just crisply say that a fuel cycle and water cycle, both are the heart of the system. So I will not differentiate. I will not go into the much more detail about the feed water tank and oil tank, all that. You can imagine and you can watch for me that the fuel cycle is also the utmost part for the combustion side and the fuel efficiency side, and the water cycle, which is not but the feed water tank and the drum level, what you are maintaining inside the boiler house. Both of them are very much important and should be, it is the heart of the boiler house and heart of the steam system, we can say. And what it requires in terms of the user point of view, that the safety should be that, so there should not be any downtime for that boiler. Efficiency should be optimum such that user can get the best efficiency. Not it be rated efficiency, but at par the best operating level with the similar kind of industry what it has got the best efficiency. Productivity, of course, the zero downtime of the boiler operation will ensure that plant is operational continuously and there will not be any production loss. Environment, yes, the combustion parameter maintained well within the limit, not disturbing much, no on-off cycles, and all that will lead to the lesser emission, lesser CO formation and lesser SPM at the outlet will improvise the environment efficiency also. And that all put together, triggered and threaded to the operation and maintenance practices will govern that there will not be any unsafe situation and will be always the efficient operation available from the boiler house. So this is what I said. I will not go into the detail. All these 4 parameters. So what generally what we came to know that we filled up through the user himself more than 800 plus boiler health scorecard report. So with this boiler health scorecard report, we came to know this spider web can give you the idea that though the safety is utmost, that is not 100% safety. Still there is a chance of the improvisations available. Safety is 85%, but efficiency is in the tune of 70%. So still there is a much more chance left to improvise the efficiency point of view. And this is the major gap which we should look upon and should identify that how we can improvise. These are the couple of plants we recently carried out that these are the efficiency boiler health scorecard available, and every weekly we are filing this report, and so we can map this what can be the best boiler health scorecard for that user can be available. This is the one of the boiler on the cloud. Sorry, I cannot showcase you the live data on the cloud due to the restriction because confidentiality, but here you can see the information is very much passed in the form of operator level, manager level and the enterprise level. So where you can see the operator will be happy to know that his take oxygen, his flowmetry data, lots of insight that at least you should monitor what is coming inside the boiler house and what is getting outside the boiler house, which is in the form of fuel flow and the steam flow generation. And the operator will be happy to know that his uptime of all this equipment with the temperature, stack parameter, combustion parameter maintained well, he will be happy to denote to the manager that these are the parameters are maintained well. And so the manager will be happy to know about the losses, minimal losses, which is indirect efficiency and steam to fuel ratio, and he will tell to the manager that we are able to maintain the highest steam to fuel ratio so that we have very less steam cost for that particular period for our boiler operational. And this is the analytics which we have fired from the live connected sites of the boiler, where you can see that there is a variations are always available, but what is the most important part, that what is the IDFD and feeder output we can still synchronize with that operating condition of that boiler. So that is when it is possible. First it is possible with the uptime. Here you can see that we have connected almost, I have taken reference of 16 customer here, but our connected sites are almost 70 plus on the cloud right now. So these 16 customer, you can see the temperature, flue gas temperature, ambient temperature, combustion parameter, fuel flow, steam flow, all these are connected. Green means it's 100% up and running. And if you can take average, the uptime is in the tune of 92 to 95%. And what it says for us, so that's how the uptime now to sustain. So just not denoting the uptime, but giving the best suggestion for that to maintain the uptime and to utilize from the uptime what can be done to further improvise the boiler efficiency and safety. So this is what we can do. We from the report we fired the four quadruple identification. First identification, the real-time monitoring, where we can play when the Forbes Marshal and user can directly connect immediately that any unsafe mishap or draft pressure going out of range, what can be done. Steam generation getting reduced due to some imbalance of the parameter, what can be done. So these are the real-time suggestion. Secondly, every weekly report can give you the idea about that what can be the further fine-tuning of that parameter, it can be feasible. Likewise, the boiler is not running at the rated pressure. The feed water temperature earlier was available slightly higher, but currently it's not available at that level. So these are the actions we can suggest and we can trigger that what can be the corrective action need to be taken to sustain this parameter. Third point, a monthly data where we can connect with the operator so that he can be trained to denote the operating condition, the IDFD and feeder parameter or the blowdown TDS set point can be well trained and recalibrated such that the operator can utilize that and can give the benefit. And the fourth is the enterprise level, where we every monthly we connect with the owner, we tell them, we hear from him that how do you find this, what kind of practices you need to improvise on that. So by connecting this dot from bottom to top, from operator to manager to the owner, and then giving back from the top to bottom, we connect the dots, and that is what the digital connect for the boiler house what we see. Similarly, it is true for not only for boiler house, for the other process equipment what we say as a steam user. So just what I said, that these are the gaps we identified, that stake O2 was not within the range, it was not operational due to the uptime. So what can be done? That we found that very low TDS, high feed water temperature, need to check the delta T of the thermic fluid. It's again the fired furnace. And so what can be done to reduce the ID gain and further improvise on the draft pressure. So these are the corrective actions we fired automatically from the report. So what can be further done? So that the boiler is connected on the cloud, all these data are available. So we connected these sites and we identify the best week of that boiler house. So how it can be? So you can see all these sites connected. The best week means what is the best efficiency parameter for that, best combustion parameter for that, and what are the best loading condition, which partial load condition, in spite of that, what can be the best operating condition can be available, that is also identified, and these are the a glimpse of that. These are the outcome of that. So you can see, and just to give you the very detailed idea that every weekly
Mr.
you can
Makwana,
see.
Mr. Makwana, can we conclude?
Yeah, just a couple of minutes.
Okay.
Yeah, I'm finishing this efficiency. Safety will take 2 minutes. Okay.
Thank you.
Yeah, so you can see this indirect efficiency band of this and this parameter. This is the optimum we identified, and we try to maintain. We suggest that you need to maintain this operating condition, this fixed condition regularly, so that you can have a best steam to fuel ratio and best combustion efficiency available. And so I will not go into this detail, but what it nutshell says, the 3-level advantage, operator, manager and enterprise level, it is combination of the safety and efficiency, where you can see the safety parameter like flue gas temperature, drum level, O2, high-low, to avoid the vibration and the combustion loss or on-off losses. frequent on-off of the boiler will lead to the unsafe condition. So all these things can be eliminated by maintaining the boiler house parameter within the band, so that all these three layers can be satisfied with the zero downtime. On the safety part, again I am taking this as example where you can see this live site connected, the mimic of the one of the live site, where you can see the draft pressure in the tune of minus 0.66. So just above the null point, just above the 0 mm water column. In spite of that, stack oxygen is in the band of 5 to 6%. And all the pressure and temperature parameters are well within the limit. So this gives the idea that boiler operating with this safety limit and the efficiency limit within the whatever the rated condition, user can get the benefit. How? So you can see that during the pandemic time, user wanted to start the boiler, solid fuel boiler, and what we identified that he cannot do any mishap. So we taken the permissive feedback so that his ID fan starts only when the drum level is within the limit, draft pressure within the limit. Again ID fan started and the FD fan should start when only then all this combustion parameter or permission will within the limit. PFN should start when the ID FD is running and all the safety interlocks are well within the limit, and the feeder should start, all the blowers are running and the combustion parameter well within the limit. So this feedback we taken as acknowledgement and we help him to start the boiler within the safe limit. Just 1 minute, sir. With this, we help to customer to improvise reduction into the on-off cycle of 134 to 14. How? It helped to reduce the ID frequency from 90 to 83 and efficiency rise of 6% and fuel saving of 10% for this one of the customer. Second customer got the benefit of the 3% of efficiency and 5% of fuel saving. I think this is it from me, sir.
Thank you. Thank you, Mr. Makwana.
Due to restriction of time, a few slides are left, but it is for the changing the technology. What Mr. Amit Vyas has, this is one of the boiler which is put in the Kapriga also. So this is the biomass fired boiler, where you can see the biomass fired boiler will be helpful. This is step-grade dynamic step-grade technology and will be very advantageous to burn the non-fossil, all kind of non-fossil fuel, and will help you to maintain your efficiency safety optimum level. Thank you. Thank you from me.
Thank you, Mr. Makwana. Now I would like to invite Mr. J.B. Suhak for his presentation.
Good afternoon, everybody. I was watching behind that. Okay, they are now sleeping very nicely. And Pandya sir, I think especially giving me this slot. And Siv Kumar rightly told, thanks to that, the slot was not given to me, but it was passed to the Suhag sir. So I am very much thankful to the Saket and the organizers always giving me the opportunity to speak something on safety. This time all are saying safety, but I want to divert that unsafe operation. Always safety, but sometimes we show the negative things, it will impact more than the positive things. In the TV also we are seeing, or in the mobile also seeing, sometimes negative things are more impacting on our mind than the positive things. So this time I chalk out some unsafe practices, normally day-to-day operation practices where the operators, engineers are neglecting. That is the live photos and live examples. I have chalked out some for the unsafe operating practice day by day or daily. We are avoiding some knowingly or unknowingly, or the practices which our earlier the seniors are following, the same practices we are also following. It is not like that. So that unsafe practices we have to avoid, and we have to change the practice in the routine. So these are some common mistakes what the normally we are seeing during the boiler operation. That is the starting a boiler without pre-purge the furnace. In case of the oil fired, pulverized fire, this type of fuel, if by mistake or by knowingly or sometime by the hurry, we are cut shorting the purging process. The purging process is very much important in that type of fuel fired process. Sometimes we say, oh, why we should wait for 5 minutes here? Yeah, light up with the 2 minutes only, nothing will happen. The boiler is already purged. So we have not to do like that. Whatever the purging condition is there, purging parameters are there, purging timings are there, it is being decided by the OEM knowingly and with the calculation. So this one thing that you have not to overcome or avoid. Ignoring furnace blowback running. Sometimes furnace is running in the backfire. We have seen the flame coming out from the windows. Even the boiler we are running. Why? Why we are running? Due to the pressure. We have not to stop the boiler, even though it is running in the back. So this type of practices we have to avoid. We all are facing, yes, you can say yes or no. Yes, all are saying yes. See the thing. So these all practices we are having, negative practices, even knowingly we are doing, so that we have to avoid. Then only safety we can say, otherwise the safety only by saying the safety it is not possible. We have to do, we have to take, or we have to ask our senior, ask our manager, ask our management that the boiler is now not to run. How we run the boiler when the flame is coming outside from the windows? How it is safe? Production is one part, it is okay. Company crises are there, everything is there, but safety is prime. As everybody knows, we cannot build a boiler in a one day. It requires a months, not day, months. Any pressure part failure, it is not available in a 1 day or 2 days. You have to wait for a days or months. So we have not to compromise in such type of things by knowingly or unknowingly it is okay, but by knowingly we are doing. 90% people are saying, oh yes sir, we are doing like that. So it is not like that. Then bypassing safety interlocks and alarm. Any emergency creates, firstly we are calling the instrument engineer. क्या गया instrument engineer क्या गया बोलो छेड़ा काढ़ी नाखो अपने. Our first step, first question is, and we are searching the instrument engineer to remove the these wires, bypass. And sometimes the operator knows 46, 70. Number he also knows. He doesn't know what the function of that wire and where it goes, what it will affect, but he knows in mind that this, by removing these 2 wires, the drum level will not, boiler will not trip on drum level, or boiler will not trip on the furnace drum. Yes, or sometimes in the DCS we are having a KL mode. See, first step we are doing putting the KL mode. So we are making our boiler unsafe. That's why instead of talking on the safety, I am talking on the unsafe conditions. So we are making our boiler unsafe knowingly, due to the pressure, due to the production load, due to the process stoppage. So this all things we have to not to consider while we are as a being engineer, certified engineer, we are giving the certificates, operation engineer, first class, second class, all this. Even though we are doing all these things knowingly. Operating boiler with chute deposition. We will see the slide how we are operating the boiler with even chute deposition. It is not affecting much on the safety, but it is depending on the safety and efficiency both. Then dirty gauge glasses. Sometimes though we are seeing the gauge glasses are not visible at all. હવે તો જમાનો ગયો ગેજ ગ્લાસનો. ટ્રાન્સમીટર એટલા બધા છે કે ગેજ ગ્લાસ જોવાની જરૂર નથી. Like this question, like this answer we are hearing from the operating staff कि गेज ग्लास की जरूरत नहीं है, अब ट्रांसमीटर इतना सारा आ गया, अब क्या गेज ग्लास करने का है. But gauge glass is the last safety, so we have to maintain the gauge glass. It is not like that we have not to take care for the gauge glass, right? No SOP followed as per OEM, right? What we are following? Our own SOP. દરેક પ્લાન્ટની પોતપોતાની SOP હોય છે. There is no standard SOP at all. Every engineer is having his own SOP. Every engineer is having his own SOP. અને કહીને જાય જો આટલું જ કરવાનું. You have to follow this only. he is telling his junior that you have to follow this only, not the standard SOP. So this practice is always be unsafe and harmful by just giving such type of instruction or laying such type of unauthorized SOPs, right? Then ignoring small steam leakages, that is we are seeing, I will show in the slides also, poor and unscheduled maintenance. Some though we are not having any preventive maintenance or predictive maintenance, these all are on the paper only, just you are putting tick, Thursday, yes, yes, yes. Nothing was done. In the field, nothing was done. But just ticking is okay, yes, paperwork is okay, but nothing on the field. So please do not follow that type of procedure. It is not like that every plant is not doing, but we have observed that many plants are just putting a tick marks. Whatever the table is given, tick mark is there. So today we have to do tick mark on the BFP, FD fan, ID fan, okay. But nothing was done in the field. So this is not to be followed. Then frequent start-stop operation, it creates a thermal shock. Knowingly or unknowingly, cut-off system or starting and stopping the boiler, it is not advisable, it is unsafe. Yeah. Right? So in FBC boilers, we are having a practice to drain out the hot bed material, right? Periodically. And we are seeing that one person is draining off and second person is standing like that only. Sometimes he is not knowing what is going to happen. So this hot bed material we have observed so many times making a injury to the burning injury to the operator, to the helper, or sometimes to the nearby area also. And the main condition we have seen in FBC boiler, whenever the line choke, PA line choke, at that time you have seen you have to see the scenario. Everybody start rushing, and whenever they are pulling out this line, heavy blowback is coming. So that is only very worst situation, and at that time nobody is following up the safety. They are not following up the mask, gloves, anything, nothing, because the boiler pressure is dropping and the production is suffering. That is only the fear of there. So we have to take care for the operation in this type of conditions. Second one, in the FBC boilers, we are used to screen the bed material, but we have to make a practice that is not to be effect on our health and our environment. Yes, this type of practices we are observing, right? This type of practices we are observing. This is the live and actual things what we are seeing in the day-to-day operation. That nothing. एक ज वक्त अपने खोलवानु છે ને खोली नाखो ना रीते. Instead of using a practice ke by put the chain and properly you are doing one time, but it is required many times. We have not to skip these things, all these things. It may create accident and unsafe conditions. Yes. Maximum the drums are used in the boiler house only. Empty drums are maximum used in the boiler house. Why? ક્યાંથી બી ઉપાડી લાવવાનું આપણે, right? And sometimes chairs, tables, everything. These unsafe things are always used in the boiler house. So we have not to make a practice. Sometimes it may create accident, incident due to that only. So we have to make a practice, safe practice, that this will not the routine practice of the boiler house. Don't make this routine practice in the boiler. I told you our seniors are done like that, so we are doing like that. So this practice are coming from our elders only. So we have to cut short. We have to make a system. We have to make a platform, and we have to use that type of system only. Yeah. This safety valve, we are having instructions that you check the safety valve daily, regularly, in the shift wise or day wise. But sometimes these wrong practices are creating a problem. Anytime there may be some leakage, or if anything happen, it may cause an accident to the operator itself. So this type of sort of practices we have to follow. This one. We are having we are very much worried hurry for the boiler inspection. Whenever the inspection is coming, we are immediately not giving, management is not giving the time. So we are so hurry. we are going to cool, no, we are not worried to cool down the boiler up to the safe level. ઘણી વખતે તો સાહેબોને અમે બોલાવીએ છીએ તો ગરમમાં ગરમમાં ધકેલી દેવાની વાતો કરીએ. અરે પણ જુઓ તો ખરા કે ગરમમાં ગરમ અમે નહીં જઈ શકતા, સાહેબ કેવી રીતે જશે? તો વી હેવ ટુ ચેક કે ભાઈ ઇનસાઇડ ટેમ્પરેચર કમ્સ ડાઉન ઓર નોટ. સાહેબ બધું ઠંડુ થઈ ગયું છે અંદર, જરાય કશું નથી. બટ હેવ યુ ચેક એની ટાઈમ બિફોર ઓપનિંગ ધ મેનહોલ? નો, નોબડી. રાઈટ ઓર રોંગ? યસ ઓર નો? યસ.
Please answer so we can judge that everybody is in
whether we are
previous
doing
mind.
corrective practice or not.
No, all are in previous mind or not, that we can know.
Yeah, that also. So we have to see ke whether the temperature really, we are giving the air, we are cooling down by the fan, everything we are doing. But we have to be assured that inside water temperature should come down below 50 degree or that. So that we have to ensure before opening the manhole, right? So this type of safety we have to take care. Sometimes whenever the boilers are in batteries, the positive isolation, 2-3 boilers are in batteries, we have to do the positive isolation. Positive isolation means we have not to rely on the wall, we have not to rely on the NRVs. સાહેબ NRV છે, વાલ છે, પછી ક્યાં જવાની સ્ટીમ? No, we have to disconnect positively as shown in the second one, as shown in another figure, right? What we are doing? We are doing just isolation of the wall. That's it. Yes or no? No. Good. Okay. So positive isolation is also very much important. For the nearby boiler, we are taking in maintenance, we are opening the manholes, we are opening the furnace area, pressure part, all these things. So we assure that steam will not come in the standby boiler. Sometimes we are using a floodlight, this halogen. સારું દેખાય ને સાહેબ, બોઇલર એકદમ અંદરથી બરાબર દેખાય, એમ હેલોજન મૂકીએ તો બરાબર દેખાય. So we have not to use that type of lights in the boiler area or boiler, right? We have to use 24 volt only or below that. So whether it is required number of lamps you have to use more, but it is not like that we have to use 440 volts or like that any these lightings. So that is also very much required, and you have to follow that practice, because we are I told whatever the practice is going on, we are adopting the same. We are not going to change. So we have to change that practice. No, now we are not using this type of thing in the boiler house whenever the maintenance is going on. This type of equipment isolation, we can say log out, take out and lock out. Sometimes though in hurry what we are doing, we are just putting one paper and that paper falls down to the bottom one. Instead of that equipment was not isolated, and the running equipment was stopped. So like that the practice is adopting in the plants. What we are observing, we have to change for the safety of the system. See the steam leakages. Even though this type of steam leakages, we are running the boiler, we are running the plant, because sir, we have not to stop the boiler. Because why? The production is not allowing us to stop the boiler. Even though there is a leakage, we are not taking care, and sometimes it may create a big incident. So that from the initial stage, if you take a step, definitely leakage may not increase and avoided. Sometimes we have observed that it has been observed that the vents, the air vents we can say, or the steam vents, that outside from the boiler house is laid like that, it is impinging on the cable trays. And one photograph, so you see totally steam is going in the cooling tower. Cooling tower. So what happened? When the operator operate this vent one, that cooling water temperature goes high and that all process chiller and everything stopped. Everybody knows what happened. So this type of mistakes or this operations creates a big issue in the system. The back fellows are laughing because they are having this type of system, that's why. That uninsulated line. right? This is a live line. In the boiler house, we have seen this type of lines. Safety is safety. Just we are saying the safety, but why we are keeping these lines like that only? Once it was the insulation was removed, after that nobody come because I have insulation वाला आटला काम माटे आवे ज नहीं. First answer stop. कि आटली लाइन माटे करवा माटे कोई आवे ज नहीं. अरे भाई you can do ना यार. It is not like that कि somebody come for this line. We also know that कि for a meter insulation nobody will come from outside. We have to do, at least we have to put a LRB. Nothing else. Cladding sheet you have not to do, but LRB at least you do, so that it is for your safety only, not for the another safety. Loss it is one side, again I am saying loss is one side and the safety is another side. Suppose this live line and something happens, some oil dropping or some cotton waste dropping or some another thing dropping, what it immediately cause the fire. So this type of knowingly unsafe conditions we are creating. This is knowingly na or unknowingly? Knowingly. Even though we are doing. This is the one good example of condensate recovery, we can say, right? Why you are laughing? Sir, we have faced these issues. We have injected this water into the boiler, knowingly or unknowingly. Unknowingly, say unknowingly, not knowingly. So, this condensate sometimes if it is not taken care, because process, we don't know the process. Where the condensate, how the condensate is coming and from where the condensate is coming, right? Sometimes direct process, direct injection is there. Some direct, indirect heating is there. So heat exchanger may leak or process heat exchanger may leak. Then whatever the contaminants of that process, it comes through the condensate only. And sometimes we are directly, instead of storing in the condensate tank, we are directly injecting to the deaerator or directly to the boiler. Then it is creating a problem. So better you have to have a condensate tank separate so that we can monitor the quality and then only allow to the entry to the boiler. Don't take a condensate directly to the deaerator. Definitely it will create a problem to the boiler if this type of quality comes to the from the process, right? See the black color, we want at least a good white color water, but it is a black color and red color. So this type of things we have to avoid, totally unsafe for the boiler by using this type of water quality. This chemical dosing, we are depending on the operator, chemist or RODM operator, they are handling the chemicals because LP dosing, HP dosing, DM operation, acid, caustic, everything. So we have to make sure to save the operation and handling system. This is the grade. DCS, SCADA, PLC, everything we are putting for the efficiency, for safety and for best operation, everything. This is actual, not created. This is live only. The manager like me when goes in the round. So the allowing mobile is a problem and not allowing is a mobile is a problem. If you don't allow a mobile, then it is a big problem. And that is also because we are very confident. Oh, boiler is running here, nothing will happen. Nothing will happen. Everything it is there. No, if something will come, then definitely it will stop automatically. Right, no? We are having all alarm, interlock, everything. So no, not to worry about that. Why to worry? We have to finish one film, one picture in a 4 to 12 shift. So this is unsafe practices. We have to stop. We have to stop. We have not to mean that we are having good DCS system, SCADA system. But if any time it may create a problem, it will collapse everything. This sort of burners condition we have observed by that nozzles not cleaning properly, or sometimes dripping we have observed in the burner. It is creating unsafe condition if you are not cleaned a burner periodically. That is again due to we are not getting a sufficient time to give a boiler shutdown. Then only this type of things may be happen, or start up stop up frequency more, right? Start stop frequencies are more, then only this type of things we have observed in the boiler, right? These diffuser conditions, right? Sometimes we observe a totally jocked diffuser conditions. So that is also creating an issue in the uneven firing of the furnace flame. Uneven flame condition. Uneven flame. Next slide I will show what will affect if the diffuser are choked or getting choked. What will be the condition and what will be the effect on the flame. See that. This is the flame impeachment, we can say. The diffuser, due to the diffuser or the flame condition, it is striking on the one side of the furnace only. See that it erodes the metal. It erodes the furnace crown metal. See, in both the cases we have observed this condition. So it is very dangerous for the boiler. This condition is not allowed at all. Because even these small mistakes only, diffuser plate you are cleaning properly and seeing the flame from the back side of glass, then we can judge that whether the flame is impinging or not. But even though we are running the boiler like that only, then definitely this will happen. Can we make this furnace again? Is it possible? No. So this sort of small mistakes, we are creating big issues in the boiler. Yes. Have you seen this type of tubes? Yes or no? No. Then it is due to the high sulfur fuel. If you are using high sulfur fuel, this condition may be there. If you are not cleaning on a frequency frequently, then definitely this sulfur deposition on the tubes. So either we have to avoid using a high sulfur fuel, or we have to make a cleaning frequency, otherwise it leads to the tube failure.
Mr. Suhak, can we conclude now?
I have made my very small, even though the time, no issue.
Your expertise is in another subject, so I will expect some more time in question answer session from you.
No issue. So, but these are the live things. That's why I told it will impact more when we are seeing live things negative, right? So that's why. Okay. So this explosion door is meant for the high flue gas or the backflow or backfiring or the high pressure of the boiler in the flue gas side. But we have observed that the explosion doors are not free at all. No. At what pressure it is operating, forget about. But it is not free only. So how we can expect that the explosion door operates at a right time? At a right time when required. So we have to check the explosion door as we are checking the safety valve freeness, like that. Then soot deposition. It is a common phenomena. I cannot. Yes, this is a critical one, right? This type of fouling, completely packed, superheater completely choked, even though boiler is running. So this condition we cannot expect from the operators or engineers, because there are parameters are there by visual also, and from the parameter also you come to know that there is a fouling and now this pressure is going high or the draft is lost. So all these by parameters only we can judge that there is a fouling in particular path. This condition of the PA nozzles sometimes we have observed in the boiler, FBC boilers. And last one, due to the channeling action, we are observing in the FBC boiler clinkerization, and due to the clinkerization, the path creates what we are calling is a channeling. 90% tubes are failure due to this only. When the clinker, local clinker form near to the PA nozzle, maybe due to the stones, maybe due to the start-stop, or maybe due to the compartment, a nearby compartment or idle compartment. This channeling effect cause the nearby tube failure due to the high velocity creation and particular impingement on the particular bed coils. Thank you very much. Thank you, sir.